Today in this video, we will configure a backdoor link in ISP1 from Customer Router 1 to Customer Router 6. In our network, Customer Router 1 is reaching Customer Router 6 and vice versa, via ISP1 and ISP5. Now, to provide a protection link, we will establish new OSPF adjacency via VRF Black through the link between Customer Router 1 and Customer Router 6. For our task, establish a backdoor link between Customer Router 1 and Customer Router 6. Ensure that the primary route is via ISP1. To do this, follow the steps below. Steps 1 and 2 are pre-configured to save time. New subinterface on the link between Customer Router 1 and Customer Router 6 is already configured and tagged to VRF Black. Let me show these configurations quickly. Before we proceed, let us verify the OSPF types of route in Customer Router 1 and Customer Router 6. As we can see, the routes received in Customer Router 1 is an external since the domain ID of the PE routers are different. Let me show you this in our PE routers. In XE Router 1, the domain ID is 0.0.0.112, which is based on the OSPF process. The same domain ID in XE Router 2. XE Router 5 has different router ID since the OSPF process is different. Let us configure step number 4 first before we establish new OSPF adjacency between Customer Router 1 and Customer Router 6. In XE Router 5, change the OSPF domain ID in VRF Black. The domain ID of XE Router 5 should be the same with the domain ID in XE Router 1 and XE Router 2. Now the OSPF domain ID on the PE routers are the same. Let us verify the received routes in the customer routers. The received routes are already an inter-area routes from external routes. In OSPF, the path selection follows these process. First, it will check the advertised prefix. Then, the administrative distance, which is 110 for OSPF. The OSPF type of routes wherein intra-area wins versus inter-area and inter-area wins versus external routes. Then the last one to check is the OSPF metric, or cost. Now, let us establish new OSPF adjacency between Customer Router 1 and Customer Router 6. Upon configuration and once the new OSPF link is established, we can see that the primary path is now via the backdoor link instead of ISP1. Our goal is to let the primary route via ISP1. Let us create a SHAM-LINK in ISP1 to achieve this. First, let us create new loopback interface in each PE router. Next, advertise the new loopback IP address to BGP under VRF Black. After the advertisement, let us create a SHAM-LINK in each PE router. To configure a SHAM-LINK, enter the OSPF process for VRF black. Then, type the area followed by SHAM-LINK. Input the source IP, which is the new loopback IP address of the router, then the destination IP address. Here for XE Router 1, the destination IP address is XE Router 5. The same destination IP address in XE Router 2. In XE Router 5, the destination IP addresses should be XE Router 1 and XE Router 2 since both routers are the PE of Customer Router 1. After SHAM-LINK configuration, let us verify the updated routes in the customer routers. The primary path is still the backdoor link. But before we continue, let us filter the received routes of the customer routers, which are the new loopback IP addresses. In each PE router, create an access list permitting the new loopback IP addresses. Then, create a route map denying the new access list while allowing the remaining routes. Then apply the route map under OSPF VRF black in redistribution of BGP. After filtering, let us check again the routes in the customer routers. The new loopback IP addresses are already filtered, but the primary path is still the backdoor link. Since the OSPF type of route is already an inter-area route, we can now change and jump to the metric on the OSPF link between customer router 1 and customer router 6. Increase the cost on this link on both ends to force the traffic via ISP1. After increasing the metric, we can see that the primary path is now via ISP1. To test, let us disable both the link to XE Router 1 and XE Router 2 in Customer Router 1. After shutting down both the ports in Customer Router 1 facing ISP1, we can see that the path to Customer Router 6 now traverse via the direct or the backdoor link. After re-enabling the ports, the traffic went back to ISP1. The backdoor link is working. For reference, refer to the configuration commands on the screen. I hope that this is informative to you and thank you for watching.